All right, so here we have everything and what it stands for, and we already talked about that we put in positive values anytime you're getting money or anytime you're taking money out of a bank. So usually your future value, when you figure something out, if you're making an investment, that's what you find out what your bank account is worth, and if you took that out, that's how much money you would have. But if you're making an investment, you're putting money into the bank, those are going to be negative values. We're going to have some questions that are loan questions. So you need to borrow $2,000. As soon as you borrow $2,000 from the bank, they're giving you that money. So the present value will be $2,000 that you get. But then your payments, you'll put those in as negative because that's coming out of your pocket and you're giving back to the bank. And on a loan one, the future value of your loan, you want it to equal 0 in the end. So we'll see questions with loans. We'll look at mortgage questions. But right now we're looking at the question of one that we did the other day where you had $500 that you were investing over 10 years at 2.25% interest. And the things that we're talking about is our payments, we're not putting extra money in. But our payments are 0. But what we pick as our payments per year is going to be important. We did it once already when we made our payments per year 1. And then because it's 10 years, n, which is the number of payments, would be 10. And then when you're wanting to solve something, so this was 0 before. When you want to solve for something, you go to the item you want to solve for. I want to find out what the future value is. Above your enter button is the word solve. So you're going to have to push the alpha button and then enter to get to that solve, and then it will figure it out for you. And I changed something. What did I change? Oh, compounds per year are 12. You've got to be careful of that, because if you change your payments per year, for whatever reason, the calculator also overrides the compounds per year. So we need this to be 12, and then it should, if I go alpha solve, it'll change it to the answer that we got the other day when we used the formula. Now, since you know that, so notice that if I make this 2, it like if I make my payments per year 2, it automatically changed my compounds per year. So sometimes what people like to do when there's no payments involved is just to put down the same in payments as they have for compounds per year, so it changes them both and you don't make that mistake. But then what would my n be? If n is the total number of payments, because now if I solve this now, it doesn't give me the same answer. Alpha solve is just over $500 because I only did 10 payments, and that's not even a whole year because now it's 12 payments per year. So I would have to have my n be 120. And that's why I put on our note here on the board that total number of payments is payments per year times the number of years. So if you did payments per year was 1 over 10 years, then that's going to be 10. If payments per year was 12, like we have right now, then this would need to be 120. And now when I go to solve this again, it's exactly the same number that we had solved before. Now, the powerful thing about this program that our first formula doesn't account for is, let's say you have $500. That's great. It's wonderful. But your parents say, you know what? We want you to start saving for your education, for university. We're going to give you $500 in a special account right now that is a special savings account that pays 4% interest. Ooh. And we'll give you $50 a month to put into that account. So this program can account for that, whereas our other formula, you would have to do things separately to figure that out. How does this program? Well, you've already got $500 in the bank. Then you get to put an extra $50 a month into that. So we go negative 50. And now, let's say that's per year. Let's see what happens after 1 year. Does it make sense that 12 times 50 is another $600? So you got your $500 you started with. You're going to put another $600 in. That's already $1,100. But you're going to be making interest on interest and interest on the different investments as it comes in. And this program will figure all of that out and you'll have an extra $31 at the end of the year from interest. So your $1,100 is what was invested and the $31. The nice thing about this program and why I like to teach it is because if you know how to use it, it is one of the most useful tools to have quickly to figure out stuff when you're buying a car. Later on, you're going to be buying a house, and you can figure out all sorts of things quickly with this program. So we're going to run through a couple just hypothetical situations before we go into solving some of the questions here. Let's say you're buying a car. How expensive a car are you guys going to buy? A pretty cheap one? $10,000 car? Okay. So what you can do is you're going to say, well, I need to get $10,000 from the bank. So since the bank is giving me that money, it should be positive. So I get $10,000 from the bank. How much can I afford to pay per month? Or how long? You get to create the scenario. Either you can figure out how long it's going to take me to pay off my car, or you can say, I want to pay off my car in 3 years. How much do I have to spend per month to do that? So you can set up a whole bunch of hypothetical situations, get answers for those hypothetical situations right away, and then that can help you make a decision whether or not this is the right car for me, if I can afford it, rather than having someone who's trying to sell me the car tell me, yeah, you can afford this. Yes? No, a percentage is always going to be a positive number. Since we're buying a car, banks are not giving us that low interest rate, it's probably higher, 5 or 6%. Depending, some car dealerships have lower percentage rates and they just sell cars for more. So it all works out about the same. So we got, let's say it's 6% because that's pretty much right now what it might be. In the end, we don't want to owe any more money on our car, so we're going to put 0 for a future value. And now you guys get to decide the scenarios. Do we want to pay this off in a certain amount of time? Do you want to pay it off in how many years? 2 years? Okay, we'll see if that's possible. So 2 years would be 24, since right now we're going to assume compounded monthly. That's almost everything does things compounded monthly for loans and stuff. It's very common. So we're going to 24, and now what we want to find out is how much do we have to pay a month to own this car? So we go to the payments, and here we can push alpha and solve. $443 a month, and you own that car in 2 years. Okay? Some other things you can figure out from this is right in here. If I go 443.21, round it, times by, I'm making 24 payments. You can do a little bit of math in here. What does that represent? What did I just do? Before I push enter, what does 443.21, which was our payments, times by 24 represent? That's how much we're going to end up paying for this car, right? We're not just because you get a loan doesn't mean that car cost you $10,000. It's going to cost you more because you're going to be paying interest. And so now we find out, okay, we're paying the bank an extra $637. That's what the interest would be over 2 years. If you're okay with it, then that makes sense. But you might say, $440, I don't know if I have that much a month after my rent and everything else. I think I'm going to opt for 4 years instead and see what a difference it makes. So now I'm going to go back to my payment and solve again. And now instead of 440, I'm paying $234.85. And you're like, hey, that's more manageable. I think I could do that. I'm going to pay more in the end as a result, because if I go here and now times that by 48, that's going to be the total I'm going to pay for this car on this plan. And now I'm paying $11,272.80. So I'm paying more in interest because the bank, I'm paying it off slower. But I want that car. This is what makes sense for me, so I'm going to go with this. Around with is say you know how much you can afford. I know that I can do $300 a month. So in my payment here, I'm going to put $300. Now, since that's money coming out of my pocket and going to the bank, it's going to be negative. And now I can go up to n and go alpha solve and say, oh, it's going to take 36.5 payments. Now, my payments are 12 a year, so that's going to mean 3 years. So if I can afford $300, it's going to take 3 years. Now, where this is buying a car, we notice that our interest rates, we're getting charged $600, $1,000. That's important. That's a lot of money. But it's not as much money as when we decide to buy a house. Okay? So let's say, what does a common house go for these days? Common, just about 300,000. Okay? So let's say you get $300,000 for your house from the bank. Now, most people pay off their houses over 25 years. It takes a long time. So for number of payments, be 25 times 12. And interest rates for houses right now are around 3.5%, 4%. Let's say the first company that you go to says, we'll give you 4%. Again, you want to pay off your house in the end, so your future value will be 0. In Canada, by law, the compounding per year is 2 for houses. So that's kind of good. They're not compounding as much. But we already saw from the other day that it doesn't make that huge of a difference. It makes a little bit of a difference, but not as much a difference. And we're going to really see it now, what that interest rate can do. Okay? So what will our payments be? How much do we have to pay a month if we want that house? Just about $1,600. You pay $1,600 a month for 25 years, and then the house is yours. How much did you pay for that house? Well, we can take this amount here and times it by 300 payments and find out that you ended up spending an extra $173,000 to the bank to own that house. Now, a house, unlike a car, is an asset that appreciates in value. So it might be that at the end of 25 years, your house is worth that amount anyways, so the fact that you paid that extra interest is kind of compensating. Well, with your car, it's not like, oh, my car is now a year older and it's worth more than when I bought it. That doesn't happen. Yes? Maybe. It would take a very long time for your car to be worth more. Then it has to become a collector's item. And then you also have to have bought a car to begin with that one day might be a collector's item. I don't think my Toyota Corolla will fall into that category down the line. So this is what 4%, $473,000, about $173,000 of interest to the bank. You do some shopping around and you find another mortgage company that is able to say 3.5%. And you wonder to yourself, well, how much of a difference does 0.5% make? So I'm going to find out what our monthly payments are now. They're just under $1,500. Okay? And now if we take that and multiply that by 300, 449. So you're saving yourself about $30,000 with a 0.5%, which is significant. Okay? $1,497, you say you just got a raise, all of a sudden things are good, you're making lots of money, and you can afford to spend $2,000 a month. So you up your payments from the recommended. Okay, and since I remember 473, I'm going to compare this back to 4 because that number is etched in my head right now. Okay, you can afford $2,000 a month. Well, instead of having to make 300 payments, now you can find out you're going to pay off your house in 100 less payments. And this too is going to make a significant difference. We're going to compare times 207.5, 41.5. By upping your payments by $400 a month, you end up saving $62,000. A little bit of knowledge about interest rates and about money this way can save you thousands and thousands and thousands of dollars in your life. Because what most people do is they get their house at a point in their life where they need a house, but they're not making a lot of money yet. Because with most jobs, the more time you work, your wage goes up, you start making more money, or your business grows, and you're doing better, hopefully, when you're 40 than when you were 30. And you're doing better yet when you're 50 than when you were 40. Hopefully. That's kind of, you know, as you gain knowledge, that's why we go to school, so we get smarter, so we can do better things. That's the goal. Now, what happens with most people is they get their mortgage, and they can only afford a small amount. And when they start to make more money, they're like, woohoo, we got more money to play with, and they use that money to play with, and that's fine, and they like that, and that's good. But they don't realize how much money they could actually be saving and making if they would decide to change and put more money against their mortgage. We see all here just $400 a month, if you could afford that, in the end, saves you $62,000 or $60,000, just about. That's a lot of money. And then with the $60,000 plus 200 means that divide that by 12 is what? About 16, 17. So you're going to be paying off your house 8 years earlier, and then you're going to have 8 years where you don't have to pay $2,000 a month, so you can go to Mexico every month. Yes. That's right. So when you get your mortgage and when you sign your mortgage, there's usually a clause in there that says you can pay a one-time payment per year without penalty. If you win the lottery and decide to pay off your whole house, there's usually a clause in there that says there's a penalty for paying off your whole house because the bank wants that extra $115,000, right? That'd be like, I would want an extra $115,000. So if you are already going to pay it off early and not give them that, then they're out a lot of money, so they have a clause in there that there's a penalty for that. I don't know. I've never had to pay, never won the lottery yet. I'm working on it. I think my main problem with winning the lottery that's going to prevent me from winning it is I never buy a ticket. And I think that you need to do that first before you have a chance of winning, but I haven't figured that out yet. But I have figured out the chances of winning a lottery, and that's the reason I don't play the lottery. Anyways, we'll get to that in chapter 8. Yes?
So when you're paying off your debt, you still have to pay more money for the penalty.
Yeah, when you're paying off your debt, you still have to pay more money as the penalty. Although, like we were saying, some of them have clauses that say you can pay up to 10% or 15% or 25%, usually not that high, of your original principal per year. So you can do a one-time lump sum payment. You can also increase your payments per month by a certain amount, up to a maximum amount per year, and you're allowed that every year. So if you do make more money and you decide, I'm happy with how I'm living right now, I'm going to take the extra money that I'm making and put it against my mortgage, that's going to work for me. It's very hard if you start to live a certain lifestyle and then decide you want to put more money so you don't live that lifestyle anymore. That's a hard thing to do. Yes?
Like when you just came across the lottery, it's like, oh wow, that's confusing. Because I just saw this thing. It said a woman won a $1.3 million lottery. She hid it from her husband and immediately divorced him to avoid giving him half. Domino ensued due to a family code statute that penalizes spouses for falsifying debt.
We talked a little bit about how the interest rate makes a difference. We looked at 4 and you managed to get it down to 3.5. I mentioned the other day in class that in the 1980s, interest rates for houses went up to 18%. So what does that mean for your house? Now, houses back in the 1980s were obviously not as much money. So let's just say you had a $100,000 house, not a $300,000 house. And at our 4% and paying over 25 years, a $100,000 house right now would only cost you $530 a month to pay off. That's not bad. Okay? Now interest rates went up to 18%. Instead of paying $500 a month, how much of a difference does this make? You're paying $1,500 a month. Okay? This is really close to the number we had before when it was $1,500. What did the house cost? Well, we'll figure it out exactly. Why not? 38 times 300 payments. Okay. So this is your $100,000 house. $440,000 is what you would pay for it in the end if you waited the 30 years, which you would have just paid it off about 5 years ago. If this was 1980 to 2010. Or not even 2005, 25 years, you would have paid it off. And you would have spent $440,000. So what happens is people start renting and selling their houses, and the house prices go down because people just are getting rid of them because they want, and it really affects your life. That is huge amount of money that you would be spending. So interest rates really make the biggest difference.